today's society, we're using technology like smartphones to add efficiency and value to our lives in many ways. Okay, these little pieces of technology have GPS's, Wi-Fi's capability, they're amazing. But one major problem is that the prosthetic hand market at the moment doesn't account for this. Something like 90% of all prosthetic hands on the market at the moment actually don't have a way for the prosthetic hand to interact with the touchscreen. They don't work with the touchscreen, which is absolutely horrible. You're denying amputees, who are people who are already disadvantaged, this amazing technology. So what we decided was that we wanted to create a prosthetic hand that could work with the touchscreen but wouldn't compromise, basic functional ability. So what we made was this prosthetic hand. We have a touch capable tip on the index finger here. So this tip here is able to effectively and seamlessly, provide input to a touchscreen like this.
So as you can see here, the input mechanism for the touchscreen is pretty good. You don't need to apply too much pressure. It kind of works, with the same amount of pressure that you usually use with your finger. And yeah, you're just able to type a simple message using a keyboard.
And we have a two-motor system where we have, three grips. So we have a pinch grip, a power grip, and a three-finger grip. So what this prosthetic hand is going to do is it's going to allow you to use smartphones, but it will also allow you to do everyday tasks, such as picking up cans, picking up your Mikey, touching on your Mikey.
So what you saw just then was an example of the pinch grip of the prosthetic hand. Now this is an example of the three-finger grip. So what we're using the hand for is gripping just a simple, average-sized vitamin container. And as you can see here, I'm shaking it up and down, rotating it. The grip is quite firm. It's not going to slip out. And you're able to manipulate a lot of objects using this prosthetic hand, given the malleability to the surface mechanism of the fingers. So an additional feature that we added was a stationary thumb that's actually shaped like a hook. So you can actually use the thumb to hook onto simple bags like this. And you can see it holds pretty well. So the way we've designed the prosthetic hand, it's actually going to be able to be controlled by electrical signals in the amputee's forearm. So when the amputee actually flexes his muscles, that's going to be able to open and close the hand. Right here, we've actually simulated what that signal will look like after it's gone through some processing with some potentiometers. So that was just a quick demonstration of the features of the hand. Just a quick recap on all that the hand can do. It's able to use a touchscreen, unlike 90% of all the prosthetic hands on the market. It's got three types of grips, so pinch, power, and three-finger. The fingers are malleable to a lot of round surfaces. We've got the curling mechanism there that our fingers actually have. And it's got a very long battery life, in excess of 1 day, in terms of continuous usage. So this product is going to add great value to the lives of amputees who have undergone a wrist disarticulation procedure. And the product is actually at a very low cost, only $113 for all the features just described. So, bye now.